We get ready for our next week's oral essays. Since we had this week off for chatting, we're looking at topic 5.5 to catch up a little bit, and that deals with radical expressions. And you recall from our flipped classroom lesson the parts of a radical expression. Number one is where you would have the index number, and if there's no number there, it's a 2. There's never a 1. Underneath number 3, which is called the radical sign, we have what is called the radicand. So there are the parts of the radical expression. Now, what is the protocol for simplifying a radical expression? All right, number 4, some background. We say a radical expression is in its simplified form when there are no longer any perfect squares, factors in the radicand. So here we have the radicand of 98. Now, is there a perfect square factor there? And you might say, well, I'm not sure. What do I do? Well, you would tease this apart, find the prime factorizations. If you divide 98 by 2, you get 49. 49 is a perfect square. So what you then do is, in 2 sets of radical signs, in the first one, you put the largest perfect square factor of 98, which is 49. You then take whatever multiple factor is left, and that is a 2. So here we're going to have 49, the square root of 49, the square root of 2. Now, what is the square root of 49? Well, it is 7. And then the square root of 2 is a radical with no perfect square factors left in it, so that would go under this. So reviewing then this step, in order to be simplified, you can't have a perfect square factor as part of the radicand. You set up 2 radical signs, put the greatest, the largest perfect square factor under the first one, and then whatever's left under the second one, and then take the square root of that, and then what's left here gives you the simplified form of that radical. Next question, what is the protocol for rationalizing the denominator? Now we say normally we don't want to see radicals in the denominator. So how do we get rid of that radical? Well, the process is called rationalizing, changing it from irrational to a rational number, the denominator. Now, from past lessons, we know we can multiply any fraction by 1, and we're going to choose a form of 1 that will make this denominator rational. So the most obvious form, and again, this relates to our lesson, is the square root of 3 over the square root of 3, which is a 1. Now, the square root of 3 times the square root of 3 here gives you the square root of 9, which is 3. And then here, I should say 7 times the square root of 3 is 7, the square root of 3. So now you're left with the answer, which is 7, the square root of 3 over 3. You have made an irrational denominator into a rational denominator through the process of rationalizing the denominator.